See, we have already seen that pointers are passed to functions. Pointers can be returned from functions. Normal values can be returned from functions, values can be received. In fact, return type can be void, can be int, can be float, can be char. Similarly to a function, as argument you can pass integer, float, character, whatever. Now the point is, if we create an array using malloc over here, and a pointer and a malloc, question is how I can pass that array to a function. So what can be the idea of this program? The program idea is create an array and keep arrangements for insertion of an element into the array and deletion of an element from the array and deletion of an element from the array. See, you have to understand the logic. What I am saying, an array is there. Say the array is, say it contains 5, 9, 4, 2, 7, 3, 6 and so on. This is the array which has been created. Now suddenly I say, now the program asks from the user, where do you want to insert? Say I want to insert 8. In which position? In 4th position. See what I say? I say an element 8 is to be inserted. Where? In position 4. So the program should comply. The program should insert this number 8 in the position 4. So if you look at this array, this is position 1, 2, 3, 4, this is the 4th position where element 8 should be inserted. So the look of the array now should become 5, 9, 4, then the element 8 in the 4th position. So the 2, 7, 3, 6 should be shifted down. So this is the logic, this is the program talking about. So let me first create the array and input the elements first. We create the basic array, then the question of insertion and deletion comes. So let me go like this, int star a. Definitely this I am trying to go for an array. So how do we create that array? A is equal to int star, if you remember, malloc. Why int star? The typecasting. A is int star. So before you assign it to A, you typecast it. Because malloc returns void star. Malloc is a function. It returns void star because it does not know where it is to be pointed. So you typecast it to int star before assigning it to A. Now so malloc, how many elements? Exact n. So this n has to be over here accepted from the user. So this n is the number of elements in the array initially. So definitely n into size of int. So these many integers, n number of integers have to be allocated. So first thing is you ask the n from the user, printf enter, this is really bad, enter the number of elements. Once you say enter the number of elements, it is expected that the user will enter the number of elements in the array initially. So I simply scan it, scanf %d ampersand n. I get this n. So that many size, that sized array is now allocated using malloc. What to do next? Now I will have to ask for the values from the user. Is not it so? I will have to tell the user printf enter those elements one by one. So enter the %d elements 1 by 1. And what is this percent D? This percent D has to be replaced by n, because n number of elements user have said. So I will have to scan. So for scanning n elements, I need a for loop definitely. So for I equal to 0, I less than n, I plus plus. What will I need to do? For I equal to 0, I less than n, I plus plus. What will I need to do? I will have to scanf these elements one by one. So scanf percent D ampersand AI. I need to scan the elements one by one. So A0, A1, A2, A3 and so on. All the elements are scanned one by one. So once these elements are scanned, after that the question of insertion comes. So you have scanned it. Better is let's print this array once before inserting or deleting. So printf the array after, sorry, the initial array, not after, the initial array is. You can just print the contents of that array, just print the contents of that array to see what is being printed. So the initial array is, once again that for loop, for I equal to 0, I less than n, I plus plus. I have to keep on printing the elements of the array. So printf percent D followed by two spaces you may give, and then AI. That is all the elements being printed one after the other. Now the question of insertion. So for that I will have to ask for the user printf enter the element to be inserted, enter the element to be inserted. Isn't it? So enter the elements to be inserted. I will have to tell that to the user. So it is expected that the user will enter the element which is to be inserted. So you scan that element. I told the element and in position. So this you scan in percent D, maybe element, ampersand is needed. Scanf percent D ampersand element. You need this. Isn't it so? Also you need the position. So printf enter the position where the element is to be inserted. These two things are basically needed. Enter the position where the element is to be inserted. Is not it so? Once you know that the position where the element is to be inserted, you also know the element that has to be inserted, that is scanned earlier only. So this also you scan. After that what? Scanf percent D ampersand position. So after that what is to be done? See, this element that I have scanned, that has to be inserted in the position that I have scanned. So for doing that, let us call the insert function. What I want to do is, I want to send the array to the insert function. But remember how to send the array. Now over here I will tell you, when you are writing int star A is basically an address. You are saying malloc n into size of int. Say user has said that user will enter 6 elements. So 6 elements to be inserted means 6 into size of int. That is 6 integer positions are created, and that has been received in A means the initial address has been received in A. So the 6 element integer positions have been created starting from A. That is here, here, here and so on. How many memory locations? You know it, 12 memory locations, because 6 elements means 12 memory locations. So in this way, if you continue, there are 12 memory locations which have been created for insertion of the element or insertion of the elements in the array. Now when you send something, send this array for insertion, what can you send? Cannot you send this A? Because after all, A is the starting position. You know, in an array, A is the starting address from where the elements are kept. So A is the starting address. If you have to insert and you have to send the array, why don't you send the starting address? Now see, This is automatically an address. You remember, we are talking about call by address. If you just send a value, then that value cannot be changed. You remember that value A cannot be changed. It can be changed within the function, but the main value cannot be changed. Main value does not change even if you change the value in the function. But over here, A is an array. A is the starting address of the array, is not so? So if you send this A, you have to receive it in a pointer. Now any change that you do, if you hold the pointer and do the change is happening in the main location. Say over here, if you send A, then you are sending the starting address. So if I access by the content of that, then directly these locations will be changed. So the values will be changed. So sending an array is automatically sending the address. It should work normally. But if you send an array, its size also needs to be sent. That is, n needs to be sent. Is not so? Now will n change? This size will change in the array. Yes, because if you insert an element, then there are now not n but more elements. But you created the array for n elements only. Here I want to make a point. In this program you are giving the option of inserting elements. So if n elements are initially there in the array, if n elements is there, elements are there initially in the array, more elements can be inserted, means the size of the array can be more than n in future. So it's not safe to allocate an array maybe twice the size. See this, 2 into n into size of int. Why I do? I allocate the array twice the size of the initial array, because more elements can be inserted. Yes, it can be deleted also, but can be inserted, so size may increase. If deletion happens, no problems, size will decrease. Now over here in insertion, the array size will increase, it will change. So if you have to change the size of the array, it is better to send its address, because then this size will be changed and that will be reflected over here. If you only send the n and n is incremented in the insertion function, insert function, then that change of n will not be reflected over here if you don't call by address. So you call by address. You need to send the element that is to be inserted, and you need to send the position where it is to be inserted. See, what have you sent to insert? You have sent the array, that is the initial address from where the array begins, so that you can access all its elements. You send the size of the array by address, so that the size can be changed after insertion. It will increase, the size of the array will increase by 1. The element to be inserted and the position where it is to be inserted. So these are the 4 things you need to send, and you expect that insert will insert. Does insert need to return anything? Answer is no. Insert does not need to return anything. Why? Because insert will only insert in the array. It is receiving the array by address. It is receiving this array by its address. So the change that it will directly make to these memory locations. Their contents need not be sent back. So insert will not return anything. Insert is void insert. I think I could make this clear to all of you. Say void insert. If I write void insert, I need to receive the array. In star A is needed, the array, the initial pointer, and also the size. So I receive it by int star size. The size has been sent by address. The address of n has been sent, so I have to receive it in a pointer, int star size, and the element to be inserted, and the position where it is to be inserted. So insert the element, maybe I call it say element, I can call it element. I don't change the name. And position, I call it POS. I don't write the entire thing, position not needed. I just call POS. I just remove these things. And now I will start with the function now. Insert function, how it is to be written. Please have a look into this. Now an element has to be inserted in this position. So say over here in the fourth position 8 is to be inserted. So user will say fourth position, user will understand this position, but for C it is not 4, it is 0, 1, 2 and 3. Please understand. User says it's fourth position because according to the user it is 1, 2, 3, 4, fourth position. According to C it is not fourth. According to C it is 0, 1, 2, 3. So if user says 4, then you have to insert in 3. That means the insertion should happen in A position minus 1. I can access it by this array. You get my point. And in that position the element has to be inserted. But wait a minute, there is a problem. If you just copy this element 8 to A position minus 1, that is in our example A3, that is this was the array initially. You are just writing A position minus 1, that is position is 4, so A3 equal to element being 8. So A3 equal to 8. You are only changing this 2 to 8. But that should not happen. Insertion means 2736 should shift back, making like over here. 2736 should shift, making a space for 8 to enter. So yes, this statement is correct, A position minus 1 equal to element. But prior to that, the shifting of other elements should happen. Now for that shifting, you remember, if I start from here, if I take this 2 and copy this 2 over here, 7 will be overwritten. The 7 will be gone. Then when you will try to copy this 7 over here, you will basically copy the 2 over here again. Is not it so? So you cannot copy the 2 to this position of 7 first. What you need to do is you need to start from end. What you need to do is you firstly need to shift this 6. This 6 you need to shift. Where? Over here. Over here you need to shift. Then you need to choose this 3 and then shift it. Where? Here. Here you need to shift it. Then you need to choose this 7 and you need to, this 7 you need to choose. And where do you need to shift it? You need to shift it here. You get it? Then this position is as if empty. As if. So you just copy the 2 or not, or again 2 you need to copy also. You need to copy this 2 from here and you need to copy it here. Then you can say as if this position is empty where you copy this 8. So you have to start from the end. What I do is for I is equal to which position? This is n minus 1, remember. This position is n minus 1. This position is n. So you start from for I equal to n. You get my point? And how long I am coming to it, and I should be decremented every time. Starting from n. From starting from n, you go on decrementing. And how long? Up to this position. See, this is position minus 1. Is not it so? So this is position. So you have to go up to I greater than equal to position. Not less than equal to, greater than equal to. As long as I is n, n minus 1, n minus 2 and so on, all are greater than positions or equal to position. This is position. Up to here you bring. Every time you copy a I minus 1, this is the number you copy. Where? To the position ai. Is not it so? See, when I is n, you write an equal to an minus 1. That is an. See, this is an equal to an minus 1. Next is this. I decrements. An minus 1 is equal to an minus 2. An minus 2 is equal to an minus 3. n minus 3 is equal to n minus 4. It stops over here because this is position. I greater than equal to position. Lastly, a position is equal to a position minus 1. This is a position minus 1. This you copy where? Here to a position. Is not it so? Now a position minus 1 is empty. Where you write this element. You don't need to return anything. You simply return. You can explicitly write the return. You can avoid it. See, this line return is useless. This line return is useless. Even if you don't write, it will automatically return. So you can avoid that. You may not write. Even if you write, doesn't matter. Okay? So you just complete this insert function. Over here you need to declare only the I that you have used. Nothing else you decided. Nothing else you changed. Nothing else you use newly. But one thing is left out. You have changed the size of the array. By inserting one element, the size of the array has changed. And another thing, this is not n. This you have received in size. Not in size. You have received the address of size. Because main function did not send you n. Please have a look. Main function sent you the address of n. Main function sent you this, the address of n. So this address of n you have received in a pointer, star size you have received. So this is not n, this is content of size. Content of size is n. Is not it so? Content of size, that itself is n. Is not it so? Address of n has been sent, which you received in content of size. So definitely content of size is n. Now, last thing that you need to do is the size will change. It will increase. If you write star size is equal to star size plus 1, job is done. Why? Because star size equal to star size plus 1 means you are basically accessing the content n. So the n is getting changed. You sent the address of n, is not it so? You sent the address of n. So you received it in the pointer size. So you change its content means you are changing n directly. So this is insert and this job is done now, and all changes have been done in the array itself. See, you sent this A. This A was received over here, A. So this A that you receive is directly this address. When you send this A, you have sent this address. This address you had received over here in A. So when you are accessing A0, you are basically accessing which A0? You are accessing this same A0. Is not it so? So this job is done. Sending an array is possible. You get my point? This way it is done. Now, once this insertion is done, now I can again print the array and check what is the condition now. So also the size, remember this n has changed. The size n has changed. N is now the new value. Doesn't matter. So this will still work. So I will just copy this and paste. Sorry. So this is selected. I just need to copy this. And I will just paste this. So this is not the initial array. So the array after insertion is. The array after insertion is. Now you print for I equal to 0, I less than n, I plus plus, printf %d ai. Your job is done. This will work absolutely fine. Only thing is you need to declare the variables you have used. You have used star a, no doubt. You have used n. You have used I. You have used element. You have used position. All these variables you used. Have a look. Anything else that you used? N. You declared n. Next I. Yes, you declared I. Next you have used element over here. Next you have used position. So this is the thing you have used. So everything you have declared over here and everything you needed over here has also been declared. Now you can run it and check. 25 errors because I did not comment. Okay, so comments done. Over here also, did you use yes? Something more were there which you did not comment out. So these things are needed to be commented out before you run a program. So this is fine. So this is commented out, so this will work fine. Let me now run this program and see. Alter, still one error, statement missing. Oh yes, still a comment is needed to be done. Now it works fine. So enter the number of elements, say 5 elements. Enter the 5 elements one by one. I should have put a enter. Anyway, I put it over here. 9, 3, 2, 7, 5. The initial array is 9, 3, 2, 7, 5. No slash n used anywhere. Anyway, I made a mistake. I should have used slash n all through. The initial array is 9, 3, 2, 7, 5. Enter the element to be inserted. Maybe I want to insert 6 in position 3. See, 9, 3, 2, 7, 5. If I want to insert 6 in position 3, that means I want to make it 9, 3, 6, 2, 7, 5. Third position for me is the position where 2 is present at the moment. If I insert 6 in that position, then 9, 3, 6, 2, 7, 5 should be there. So the element to be inserted is 6. Position where the element is to be inserted, in the third position I want to insert. So the array after insertion is 9, 3, 6, 2, 7, 5. It works absolutely fine. The array, passing the array to a function, it is possible. Like returning an array from a function was also possible if you do it using malloc. So I have done it using malloc over here and I have called it. Okay, I will check whether passing an array, not by using malloc but by using an, if you declare an array, whether passing is still possible or not, that also we will check. Anyway, but this works absolutely fine, is not it so? I need to give all those slash n which I missed out, it looked very bad. Anyway, so this print enter the %d elements one by one, and this %d elements one by one, when I'm writing here, it should be like this. So %d elements one by one. When I say enter the %d elements over here, a slash n should be there. Is not so? Enter the number of elements, this is fine. But when you are saying enter the %d elements one by one, then it will, the entering should start from the next line. So one by one you have entered. So the initial array is, after that here also there should have been a slash n so that it looks fine. Then next line, when the array has been printed, here a slash n should be there because all the printings have been done. Enter the element to insert. So here it is done. Here I will enter the element and I will automatically press enter, so a slash n is not needed. Enter the position where the element, this is also fine. So the insertion has been done. So after this, the array after insertion is, here also slash n should be there. Now the program should look nice. Say number of elements 6. Enter the 6 elements one by one. 8, 7, 3, 9, 2, 4. The initial array is 8, 7, 3, 9, 2, 4. Enter the element to be inserted. I want to insert 1. In which position? In 4th position. If I want to insert in the 4th position, then in the 4th position right now 9 is present. See, 8, 7, 3, 9. 9 is present in the 4th position. If I want to insert 1 in the 4th position, then I want to make it 8, 7, 3, 1, 9, 2, 4. So here it is 8, 7, 3, 1, 9, 2, 4. So this program works fine. Now one last thing that I need to do, remember, if after inserting I want to delete, isn't it? So I also maybe I want to delete. So over here I may do the same thing, printf enter the position from where deletion. See here which element to be deleted may be given, or you may ask the user the position where the element is to be, from where the element is to be deleted. So it's better to ask for the position. You ask from the user, enter the position where you want to delete, position which you want to delete. So I just copy this part and paste this part. I will ask the user, enter the position, I just meant it, enter the position from where an element is to be deleted. I just ask the user the position, you tell from where you want the deletion. So I will go back and show you the example so that you understand. Say over here I may ask the user, this is the array 5, 9, 4, 8, 2, 7, 3, 6. What is the position that you want to delete? So user may say the position is 3. I want to delete the position 3. So for the user's point of view, 3 is this position, 4, 5 is 1, this is now 2, this is 4, 3 position. So after the program runs, your array should now look 5, 9, 3 is in 4 is in position 3. See, user wants to delete position 3. What is there in position 3? 4. So 4 will be deleted. So what will be there? 8 will come front, 2, 7, 3, 6. Is not so? Position 3 has to be deleted. So it is deleted. Now I come over here. So this position from where an element is to be deleted, I asked from the user. I have scanned the position. What is my job now? Insert was called. Like that I will call delete, or delete is actually a keyword which you will learn later. You may not call it delete. It is better to call it maybe deletion. Deletion. Or say remove. Like insert you say remove. Why not you call it remove? Remove what? You need the array A. So once again array A you are sending means you are sending the address A. The size again you need to send by address, because the size will again change. The size will decrease. So if you decrease the size n in the function, then this decrease will not affect over here if you send by value. So you send by address. Then you need to send the position from where you want to delete. Is not so? So this should do the job. Removing the position, you are sending the position. Element is not needed because the position has to be deleted. So no new element is being inserted. So the element is not needed anymore. You only ask for the position and you tell the remove function to delete that position. So let me write that remove function. See how you write it? Very simple. Remove. It looks like the return type will be void itself. You are removing. So the return type you don't need to return anything because you are directly changing the array. So int star a, int star size once more, and the position int position. So you need the array, you need its size, and you need the position. Next what? So what you need to do now is, again you need this I. Now when you delete, when you insert, you started from the end. But see, when you delete, what will you do? If position 3 has been given, then according to the user, which one is position 3? The position where 4 is present. Why? Because according to the user, this is 1 position, this is 2 position, this is 3 position. But according to C program, this is 0, this is 1, this is 2. So according to C program, this is position minus 1. Remember, this is position minus 1, which is to be deleted. So this is what you do, how you do. Starting from this position, position minus 1, you can start. From position minus 1 you start. Copy the next element over here, that is this position, you copy here. Is not it so? Again, this position you copy here. Sorry, here. Is not it so? Again, this position you copy here. How long will you do so? Until and unless you reach this position, which is n minus 1. This has to be copied to this position. Is not it so? So what to do? I told you have to start from where? You have to start from here. According to the user, this is position 3. But according to you, it is position 2. So you have to start from I equal to position minus 1 for I equal to position minus 1 and go up to I less than n minus 1, because less than n is the last position. What you do is, the last position you are accessing by plus, like this. AI is equal to AI plus 1. Why you check out? Because when you are in position 1 minus position minus 1, you are saying A position minus 1 equal to A position. See, I is position minus 1. So you are writing a position minus 1 is equal to a position minus 1 plus 1. That is a position. So a position you are copying to position minus 1. Then you are copying the next. In this way you are copying. The last one you check, n less than n minus 1. So the last is a n minus 2 is equal to a n minus 1. And a n minus 1 is the last element which you copy to n minus 2. So your job is done now. What to do? Your size should decrease. Array size should decrease. Star size is now equal to star size minus 1 because you deleted. It is often seen a good practice to return the element which is being deleted. It is often used by the programmers. That is, over here, when the user has said 3, position 3, then this position 3 is 4. This 4 will be completely removed from the array. See, in this array nowhere 4 is to be present. This 4 which is deleted, you return to the main program. So this 4 is deleted now. You copied this 8 to this position. See, this 8 you copied to this position, deleting the previous number 4. All other elements are there, but this 4 is being deleted. So before you delete, you use another variable called element, where before you start the deletion process, you copy element is equal to a position minus 1, which is to be deleted because position is being sent, remember. So position minus 1 is to be deleted. According to the user, 3 is the position. So 3 you will receive over here, but actually you need to delete a2. So that you copy to element, so that at the end, you, before you complete this thing, you return the element. In insertion it is void, but in deletion, in removal, it is not void. It is a good practice to have it int. You return the element that is being deleted. So here you end it. This program should run absolutely fine. Only thing is the element being deleted can be received in element. Is not so? And here you may write printf. See, printf, you can use a /n because in the last, this was the last printing where /n was not used. Printf /n, you just write what? That same thing, the array after deletion, the array after deletion is : /n date this. Now that same old for loop, you can copy this, you can simply copy this and you can paste this over here. So this is, deletion is done. You can now run this program and find that what is the array. If needed, you can also print the element deleted is this. That can be done. You can have a separate printf to say printf like this, printf /n %d was deleted from the array. You just print that the element which is being deleted, where did you receive it? You receive it in element. So you received it in element. So you just print this element was deleted from the array. Now you can run this program. This program should run fine. Everything has been declared, I believe. So Alt R, enter. No, one error. Undefined symbol n. Absolutely, because you received it in size. How can you write n? No, n not allowed. N was used to explain to you, but no, it is not n, it is star size. N is not there, it's star size, isn't it so? So now let me run it. Alt R, enter. Enter the number of elements, 5 elements initially. Enter the 5 elements one by one. 5, 6, 9, 3, 2. The initial array is 56932. Enter the element to be inserted. 4. Position 2. That is, I want 4 to be inserted in the position where 6 is present now. So it should be 5 4 6 9 3 2. See, 5 4 6 9 3 2. Now enter the position from where an element /n should have been given. Anyway, enter the position from where an element is to be deleted. The array is 5 4 6 9 3 2. I want to delete the position 3. That is 6 is present in position 3. So it should be 5 4 9 3 2. Let's see. The array after deletion is 5 4 9 3 2. 6 was deleted from the array. Absolutely fine. Is not it so? So enter the position from where an element has to be deleted. That should have been /n over here, because prior to that elements were printed without /n. So the /n needs to be present over here. Anyway, let me run it once more to see that this works. Enter the number of elements 5 again. 8 2 3 7 4. Initial array is 8 2 3 7 4. Enter the element to be deleted. Enter the element to be inserted. I want to insert 9 in position 3. So I want to make it 8 2 9 3 7 4. Yes, 8 2 9 3 7 4. Enter the position from where an element is to be deleted. I want to delete the position 4. That is the 3 I want to delete. Position 4 3 is present. So see, the array after deletion is 8 2 9 7 4. 3 was deleted from the array. So do you get it? This looks absolutely fine. So this can be this you have understood how an array is passed to a function. Now you remember, when I was declaring using malloc, I could return the pointer type, but when I was declaring like an array int a5, I could not return, because that array is automatically freed after your program is over. Now when you are sending, do you need to declare it always using malloc, or maybe you can write int an? Can you write int an and avoid using this malloc totally? I think you understand what I mean to say. If I use int an and avoid the malloc, still the array is declared. Will it work? See, it will work. I will show you. 6 8 9 2 3 1 4. Initial array is this 8 9 2 3 1 4. Enter the element to be inserted 2 in position 3. So it will become 8 9 2 2 3 1 4. Is not it so? Enter the position from where an element is to be deleted. So here I want to delete, say, 5th position. So 3 will be deleted. 8 9 2 2 1 4. 3 was deleted from the array. It runs absolutely fine. Why? It did not run when I returned. See, when I returned, I declared the array over here. Here I declared the array int a5, and I wanted to return a. A could not be returned, because when you are returning, this a is automatically freed, because the function is ending. When a function ends, the array that is declared like int a5, say this array is declared as an array is declared over here like int a5. What happens when you return? This array that you are declaring is automatically freed. It worked with malloc, because if you are doing by malloc, then this free automatically does not happen, and you have not explicitly written the free. So it did not work for an array. But sending an array is working. Even if you are doing it through int an, you are still able to send this a. Why? Because this array is still not freed. Your main function has not ended. You are calling insert from main. You are calling insert from main. You can send this a, because this a is still not deleted, still not freed, because the main function has not ended. At the end of main function, a will be freed automatically. So if you write by int an, you can avoid writing the free. But if you don't use int an, if you use int star a, then everything fine. This malloc is needed, and at the end, the free a should not you forget to use this free a at the end. Is that okay for all of you? So this is the program. Here we will end this class. Before the next class, please try to practice enough of functions, enough of passing arrays, pointers. Maybe we will do one more program with these functions before we continue with strings. So till then, Thank you very much. We will come back.